Hello, I'm Mehmet Sağlık. In this presentation, we will talk about operating systems for embedded systems. Embedded systems have become an essential part of our lives, ranging from small devices like smartphones to complex hyperspace technologies. These systems consist of both hardware and software that are integrated to perform specific tasks. At the heart of these systems lies the embedded operating system, which manages hardware resources and enables the system to function effectively, especially in industries like healthcare and automotive, where requirements such as reliability, security, real-time responsiveness, and compliance with strict standards are crucial. And here in the background part, the roots of embedded operating systems go back to the 1960s with the Apollo guidance computer, a pioneering system for space exploration. In 1970s, we saw the advent of the first microprocessor, the Intel 4004, which revolutionized the computing. Through the 80s and 90s, systems like VRTX and Windows Embedded CE laid the groundwork for real-time and industry-specific solutions. Today, embedded operating systems are more widespread than ever before, enabling everything from MRIs to self-driving cars.
Now, we'll dive into the different types of embedded operating systems: multitasking, real-time, and single-loop systems. Multitasking systems allow multiple processes to run simultaneously or concurrently. These are efficient in systems that require high performance and fast responses. Real-time systems collect data from the external environment and respond within milliseconds. They are especially critical in life-sensitive sectors like healthcare. Single-loop systems are operated by running a simple loop continuously. These are ideal for basic tasks like controlling a thermostat or a temperature sensor, where the system doesn't need to manage multiple processes or real-time actions. Let's now shift our focus to how embedded operating systems are used in healthcare industry. Accuracy and precision are non-negotiable when it comes to patient care. A well-designed embedded operating system ensures minimal errors, directly contributing to better diagnosis or treatment outcomes. Other crucial feature is real-time monitoring. In critical care or surgery, patient vitals must be tracked without delay. Embedded operating systems make this possible by continuously processing sensor data in real time. Furthermore, safety and certification standards are vital. These systems must be certified to meet stringent safety regulations, particularly in life-critical applications. Another requirement for embedded operating systems is security and privacy. Since healthcare devices often operate in real time, the embedded operating systems must provide secure scheduling, memory management, and interrupt handling to prevent unauthorized access.
Hello everyone, I'm Selin. Today I will first talk about resource and power efficiency in healthcare embedded system. In resource-constrained environments, embedded operating system must maintain uninterrupted functionality. To achieve this, they are designed to optimize hardware and software performance using efficient and lightweight algorithms. When it comes to automotive industry, we can say that vehicles must make split-second decisions to keep passengers safe. For example, collision avoidance systems use radar, LiDAR, cameras, and ultrasonic sensors. The operating system has to process this data instantly and trigger actions like emergency braking, and they could lead to a serious accident. The second key point is reliability. Automotive systems control life-critical functions like engine management, braking, and airbags. This system must perform perfectly under all conditions. A failure could cause two vehicles to lose control, putting lives at risk. That's why the operating system needs to be stable and fault tolerant. Thirdly, we have resource efficiency. This is especially important in electric and hybrid vehicles. These vehicles rely on the operating system to manage computing power, memory, and energy effectively. The operating system helps reduce power consumption, control charging cycles, and ensure smooth operation. Poor resource use can increase power loss and reduce the car's overall performance. Finally, we have modularity and maintainability. A modular operating system is made of independent components, which makes it easier to develop, update, and isolate files. It also allows car manufacturers to reuse modules across different models. Maintainability means the system can be updated over time, which is essential as cars become more software-driven.
Hello sir, I am Veysel Bal and today I'm gonna explain embedded operating systems in automotive industry. Our first part is connectivity. In today's vehicles, embedded operating systems play a key role in enabling cars to communicate with each others and with their environment. This is essential for navigation and traffic updates, but also for ensuring real-time data exchange that supports safety and many other features for the cars. Next part. Potential vulnerabilities. Um, while embedded operating systems bring advanced functionality to automotive systems, they also introduce several vulnerabilities. One of the main concerns is the weakness in safety and security measures, which can leave vehicles exposed to cyber attacks. These systems must be designed to prevent unauthorized accesses, and software issues also causes significant risk for the car systems. Problems at this level can disrupt communication between components of car. Our next part. One more time, potential vulnerabilities. The other vulnerabilities is continuing with the vulnerabilities in embedded automotive systems. Another major issue is improper integration. When components don't work together with harmony, it may endanger vehicle health and human health. Similarly, internal miscommunication between subsystems can cause incorrect data handling or unstable behavior. Um, Cyber attacks are an threat, and without strong cryptography, sensitive data can be manipulated from others, and those updates must be managed regularly to patch security holes and keep systems functioning properly. Thanks for listening, sir.
Hello, I'm going to talk about recommendation for improvements and conclusion parts. Let's start with recommendations for improvements. To make embedded operating systems better in the automotive industry, there are few key improvements we should look at. As you can see, first we need to enhance reliability, safety, and security, since one mistake in a car can cost your life. That means we need to build systems with strong architecture and smart functionality so they can handle complex tasks without crashing or failing. Another big improvement that we can talk about is using adaptive schedule algorithms. These algorithms helps the system adjust quickly to different situations, so it keeps running smoothly. And especially for things like braking or evading a crash in a car, having dynamic scheduling algorithm is a must nowadays, we can say. We can say also it helps the system react instantly, which makes a big difference in safety and performance. Also, as more cars gets connected through embedded systems, we need to make sure these systems keep up So connection is a must to be improved. One improvement is adding over-the-air connection. So companies can fix bugs or add new features without needing a physical connection. This is what it helps over-the-air connection. It's way more efficient and like keeps everything secure as well. Also using something kernel-based isolation, it helps to protect this different parts of the system from affecting each other if something goes wrong or it crashes. Finally, we need to give developers better tools like simulations, automated tests, and smart development environments. Those can make it operation easier and faster. Also, we can build easier and faster, reliable and safe systems for modern vehicles. Conclusion parts. In conclusion, we talked about cars, right? When it comes to cars, timing and reliability really matters, as we mentioned. So the embedded systems react fast to avoid crashes. That's what we call real-time responsiveness, actually. Basically, it helps make sure the car does what it's supposed to do when it's the time. So if you need to brake, it brakes when it's the time. Also, on top of that, the system has to be super reliable. It runs important features like the engine, brakes, and airbags. And if anything goes wrong, it can be really dangerous. Uh, basically making sure these systems are fast and dependable. It's the key to build smarter and safer vehicles. Thank you for listening to us. Have a great day.